In last video, we discussed 10 questions from our worksheet of metals and non-metals. Now we are going to continue 11th question onwards. Okay, 11th question. Sulfuric acid turns blue litmus paper into. Sulfuric acid turns blue litmus paper into. Generally, we know the acid turns blue litmus paper into red. Bases turns red litmus paper into blue. We know this. So here sulfuric acid, not only sulfuric acid, any acid we are taking, hydrochloric acid, sulfuric acid, any other acids. So all acids in whatever the acid you are taking, in that the litmus paper, blue litmus paper turns into what color? Red color. So our option is, option A, that is red. Okay, now we go to the 12th question. What are the typical natures of oxides produced by the nonmetals? Just now we discussed. Once see the question carefully. What are the typical natures of oxides produced by the nonmetals? Generally, nonmetals, when react with oxygen, they are producing the non-metallic oxides. The non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. When non-metallic oxides are acidic in nature and when they are going to dissolve in water, they are giving rise to acids. When metallic oxides are basic in nature and going to dissolve in water, they are giving rise to what? Bases. So here our question is about non-metallic oxide and what is the nature of the non-metallic oxides. Okay, generally oxides of non-metals are nothing but non-metallic oxide. They are acidic in nature, as just now we discussed. They are acidic in nature. I will write that. So when non-metal treat with oxygen, they gives rise to non-metal oxide, non-metallic oxide. So these non-metallic oxides are acidic in nature. Acidic. When these are going to dissolve in water, they gives rise to acids. They gives rise to acids. Example, if we take CO2, simple non-metallic oxide, CO2, I will come from first step onwards. C plus O2, CO2 means non-metal going to react with oxygen, giving rise to non-metallic oxide, that is what? Carbon dioxide. When this carbon dioxide is allowed to dissolve in water, it gives rise to what? Carbonic acid, H2CO3. See here, non-metal reacting with oxygen giving rise to non-metallic oxide, that is acidic in nature, and that non-metallic oxides, when they are dissolving in water, they are giving rise to acids. Okay, here example, C plus O2, CO2 when dissolved in water, it gives rise to H2CO3, that is nothing but carbonic acid. Okay, now next slide, we go to the next slide. In this slide, when metals burn, they react with oxygen to produce. Simple. Metals burn means what is the meaning of burning? They are reacting with the oxygen. Metals burns means metals are reacting with the oxygen. When metals reacting with the oxygen, they give rise to what? Metal oxides. Metal oxides. So our option is C. Okay, already we discussed this. Next, 14th question. Which non-metal is crucial for life and is inhaled during the breathing? Everyone know this. This gas is very, very essential element, vital element, essential element for us. This gaseous element. That element is oxygen. So oxygen is one of the important element because of that it will be vital for the cellular respiration. All our cellular respiration and inside whatever the energy is releasing in our body, that is depends on what? Oxygen only. Why? Because in our cellular respiration in our body, whatever the food items we are eating, they are undergoes in oxidation process in the presence of oxygen in the cell, and producing the energy. That energy only we are utilizing in the different ways to do these all activities internally and externally. Okay, that means what? The important element in our everyday life is what? The crucial element, that is what? Oxygen. Okay, option B. Now next question, what substance is applied on wounds as an antiseptic? Here indirectly given, what substance is applied on wounds as an antiseptic? That means what? Generally here names are not given, only categories are given. Substance means which substance, which category substance is used on wounds to heal that. So generally sulfur is used to apply on the wounds because of it is act as a antifungal and antibacterial agent. So that is why generally the sulfur is used to cure the skin diseases. At the same time, it is also used as a it also has a keratolytic properties. Keratolytic properties means what? It is generally shed off the dead skin cells. So that is why to cure the skin also we use the sulfur. So sulfur is generally which categorized element? Non-metallic element. So our option is B. Next we come to the 16th question. The correct, once read the question, the correct decreasing order of the reactivity of different metals. This is very important point, because of depending on the metallic order only, metallic reactivity order only, we can uh, explain how the metallic elements are take part in the chemical reactions, which are take part in the displacement chemical reactions, how much fast they are take part in the chemical reactions. That all are determined with the help of chemical reactivity order. This is generally in the decreasing order is asking. So in these four options, which order is correctly representing the chemical reactivity in the decreasing order from left to right? That is asking. So here see, potassium is generally more reactive than sodium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium, is more reactive than aluminum, is more reactive than zinc. So that means our correct option is B. Next, 17th question. What is the purpose of concentrating the ores? Generally, we know metals are very active elements, very reactive elements. They are react with whatever the elements are available in the surroundings, then they will be forms the compounds. Generally the main source of metals are what? Earth crust. From the earth crust only we dig out the their compounds, and from their compounds we are extracting the metals. So here metals are always occurs in the form of their compounds. Okay, in that compounds, what the way we are extracting the metal? Okay, how much metal we are extracting? It is we can extract profitably or not. Based on that, the compounds are again classified, referred as what? Ores. Referred as what? Ores. Ore means what here? The metal is not existing in the free state. Generally, most of the metals are existing in the combined state only as a compounds. They are not occurring in the free state. Those metals are least reactive in nature, like a gold, silver, and platinum. They only exist in the free state. But most of the metals are highly reactive in nature. That is why they are eagerly react with the adjacent elements and occurring in the form of compounds. So that means what? Whenever they are occurring in the form of compounds with other external impurities like a sand and other dust, other impurities, that whatever that associated with other elements, that is called what? Mineral. From that mineral, which element is extract profitably, for that element, that mineral is act as what? Ore. You are following or not what I am saying? Mineral means what? The element which is associated with the number of other elements with other impurities. That is called what? Mineral. From that mineral, which element is extracting profitably, for that element, that mineral is act as a ore. Okay. So, for example, magnesite is there. MgCO3, magnesite. In these three elements are there, magnesium, carbon and oxygen. From this compound, we can extract magnesium profitably. So therefore, this mineral is act as a ore for the magnesium. It is a ore of magnesium. Actually, it is what mineral. But mineral, from this mineral, which element we are going to extract profitably? Magnesium we are going to extract profitably. So therefore, for the magnesium, the MgCO3 is act as a ore. So that is called what? Ore. But here our question is, what is the purpose of concentrating the ores? Ore means as a chemical compound. Okay. That chemical compound is not only existing simply, again it is associated with the external impurities like sand and other suspended particles. Everything is associated with that. That is called what? Gangue. So we need to remove that external impurities, whatever associated with the ore. By following the physical methods, we need to remove that external impurities. That is called what? Concentrating the ore. So here, which method which one we are using? Which one is suitable for that? To make the ore look more attractive, to increase the percentage of the desired metal in the ore, to add the impurities to the ore, to make the ore easier transport. So our option is D, to increase the percentage of the desired metal in the ore. Why? Because we are removing that external impurities, everything from the ore by following the concentrating methods. So that is the correct option. Now we go to the next question. Which metal is used in thermometers? Here 4 metals are given, all metallic elements. 4 options are the metallic elements only. But in these metallic elements, which metallic element is used in the thermometers? Everyone know that, that is mercury. So why mercury is used in the thermometers? Why not other elements? Because of, just now we discussed, mercury is the metal. It is heat sensitive metal. It is undergoes into expansion uniformly on heating. Whenever it receives the heat energy, uniformly it will be expand. It is a uniform expansion. It will be exhibit the property of uniform expansion on heating. So it is a heat sensitive metal. That is one of the reason why it is used in the thermometer. And one more reason is visibility from the glass. It is clearly visible from the glass surface of the thermometer. That is also one of the reason. Why it is clearly visible? Because of it is actually characteristic appearance. That is what? Silvery white appearance. So due to that silvery white color, it is easily appears from the glass surface. Okay, so that means it will be appear easily, at the same time uniformly expand, and one more characteristic property is there to use in the thermometer, that is it will be not sticks to the walls of the glass. It will be not that adhesive forces are very less in the mercury. Cohesive forces is more, but adhesive forces are very less in the mercury. Due to that, it will be do not stick to the walls of the thermometer, so easily expands without sticking to the walls of the thermometer, and heat sensitive metal. That is why generally mercury is used in the thermometers. Okay, now we go to the next question. Zinc replaces copper in, just now we discussed the metal activity series. In the metal activity series, we are arranging the metals from higher reactivity to least reactivity, more reactivity to least reactivity. In that metal reactivity series, we are identifying which is the most reactive, which is moderate reactive, which is least reactive. With the help of that metal reactivity series, we can find out which metal is more reactive and which metal is going to displace the least reactive metal. Most reactive metal, more reactive metal will be displace the least reactive metal from its compound. So that is why there is compulsory, we need to remember that metal activity series. So we come to the question. Zinc replaces copper in copper sulfate. Zinc replaces copper in copper sulfate. Why? Because of, when we observe the metal activity series, in the metal activity series, zinc is before the copper. Zinc is before the copper. Generally, we know the copper sulfate formula, CuSO4. This is the anionic part. This is what cationic part. When we are going to treat with the zinc, zinc is the metal, copper is the metal. But among these two metals, zinc is more reactive than in nature. Zinc is more reactive than copper. That is why the zinc is displacing the copper from its position in the copper sulfate molecule. Then the resultant compound is what? Zinc sulfate, and copper is displaced. See here, most reactive element is displace the least reactive element from its compound in their aqueous solutions. So there is a displacement reaction is occurs. So the option is B. And next, 20th question in that, what is the typical nature of metallic oxide? What is the typical nature of metallic oxide? Already in starting questions only we discussed this. Metallic oxides are basic in nature, non-metallic oxides are acidic in nature. When metals react with oxygen giving rise to metal oxides are basic in nature. When these metal oxides are dissolved in water, they give rise to metal hydroxide, they are bases. Non-metals when react with oxygen giving rise to non-metal oxides. Non-metal oxides are acidic in nature. When they are dissolved in water, they are giving rise to what? Acids. Okay. So here, which is the correct option? What is the typical nature of metal oxides means which one is the correct option? Option C, basic in nature. Okay. So in this video, we completed up to 20th question. In next video, we are going to continue the 21 onwards. Okay. Thank you.